in the draw frames. So I just want to just like get into it and sort of describe what our problem is, and show it off a little bit. So I'm going to open up everyone's favorite draw tool, which is oh right, it's not just draw, it's paint. I love the fact that I can type draw in though, that paint comes up. All right, so with paint, I think can I just do background black, make that nice and dark looking. Pencil with something nice and bright, like an orange. Perfect, that should show up. Kind of. Let me make it. There we go. All right, so here's where our problem is. We have a fixed time step for our update loop. So we now have 2 FPS happening. So if I have an orange, we have an FPS for updates. And let's say that that's 60. And then if maybe in this other color, let's find something else that looks good. This green. We have FPS for draw. And that is a terrible infinity sign. So the idea that we're going for here is we draw as often as possible, as often as the computer allows us to. But we only update once every 60 milliseconds. Now, sorry, not 60 frames. 60 frames per second. And 60 frames per second, if we, figure out what that means, which is, 1 second divided by 60 of them per second, comes out to be around 16.67 milliseconds per second. Milliseconds? No. Milliseconds per frame is how long we have. So every 16.67, we run this again. Obviously, if our update gets a little bit slower, then we run into a little bit of problems. But oftentimes, it's faster than this. It's interesting how much we can actually add, like run inside of here. Tigrigalis, hello. Think in terms of game ticks versus render frames. Yeah, exactly. And so every tick was going to be through one of these updates. Now, we're drawing as often as possible. So what that ends up meaning is that if I let's create a timeline here. If we're doing our updates at regular intervals like this, then our draws, however, are not so regular. Maybe this first one is on the same line. Then we might have a few draws that happen in between these. And then maybe you only have one. Maybe for some reason, our computer lags and we skip one. So how are we going to handle this? Because now we have these updates that happen behind the scenes. And so if we think about this case right here, we have a draw, and so we have our ball sitting here, and we want it to move over to here within one frame. So when it's got to this point, it's moved. It should be here when displayed. However, we notice that it's actually still drawn in this point because the last time that the draw animation knows about, the physics is set to here. It doesn't matter that it's going to be over here next time. And then look at this draw. We should have the ball should be here. Now, if it's small enough movements, it doesn't really matter. But if we have like a big enough movement, like if I'm moving 10 pixels per draw, and our draw isn't happening too terribly fast, then this could result in a little bit of a sort of less ideal animations, where it's just sort of hit, 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 hit. So that's what we're figuring out here. So what I really need to do to solve this is figure out what percentage through the physics tick I am for each draw. So if we take a look at this specific one right here, this is maybe we're, let's choose even another number. How about you? We're maybe 0%. For this one, we're maybe 10%. And for this one, we're something like 90%. And that corresponds to each of these. So 0% is that is right on point. 90% over here, and 10% is right here. So if I could figure out what percentage that I'm through, I could take the velocity that my object currently has, figure out what it would have moved had we been in the correct sort of, if everything continues on as they are, and then just sort of translate it over and predict where it's going to move. Now, there are going to be potential problems that lead into this. Like, what if this next update there's a collision and it's not actually here, it like goes somewhere else. That's something that does happen. And I was reading through the game design book, and it actually says, yes, that generally won't be noticed by the player. Even though it happens, but it's so infrequent that you just don't need to worry about it too much. Especially if our draws are happening at a nice, in a nice pace. And the idea here is that we're rewarding players for having good computers that can have really high draw ticks, or FPS for their draws. And for people whose computers aren't really running as fast draw-wise, they're going to be able to get the same experience. They're going to be able to predict and know where the thing is at any point of time, even if it doesn't look really as good. But if they're running on a computer that really can't handle it, which is something we're interested in because we want to run this on a Raspberry Pi 4, then we want to make sure that like the gameplay is at least there. Like that's what we're really going for. So figuring out what this percentage is, that's our goal for right now. And the easiest way to figure this out and to get the percentage is to determine what is the number of milliseconds between each loop since the loop started. So if we say that this tech 10%, if this is 16.67 milliseconds across each one of these, then maybe this 10% at this point in time, we are at 3.7 milliseconds. I don't actually. 10% would be what? 1 point. Oh, 1 point. Maybe this is like 1.7. And 90%, that would be something like maybe 15.2. Since the last update frame. So if I take this number, so if we say time since last update, and we divide that by the update frequency, which would be this 16.67 milliseconds. Now they have to be the exact same numbers. So these are milliseconds, these are milliseconds. If we're talking nanoseconds, then these are nanoseconds, these are nanoseconds. If I do this division, we're going to get something like 0.10, which if I multiply by 100, gives us a percentage. So that's actually what we're going for here. And we have everything that we need to do this in GGEZ. Let's switch over to the code. Also, hello to Gagalis. I don't think I said hello, but all right. So in our main library, we have here this remaining time. If we run this debug for the remaining time, Let our ball fall. We can see how much time has happened between the beginning of the last frame in this one. Now these are huge numbers, but if we go and take a look at our config, it's because we set this to like 2 frames per second. Set it to 60 because that's, you know, a reasonable number. And run this again, we're going to see something that looks a little bit more like, you know, something that makes a lot more sense. So we can see, okay, let's go back to a full cycle. So that's the end of a cycle, and this is the beginning of a cycle. So we start at 1.10 milliseconds, then 2.1, 3.1, 4 essentially, then 12 milliseconds. So notice here, there was a big jump between the 3 and the 4 and the 12. And that's just my computer didn't run draws in that period of time. I can't control that. That's just going to happen. What's the update frequency? 16.67 right now. I switched it back to 60 milliseconds. 60 frames per second. Man. Getting like all the numbers really easily confuses me, which is why I have to write them down. I also have a whiteboard off to the side that has these numbers for me so that I didn't forget. But yeah, we see that there's this big gap here, and I can't, like, it just happens. This computer, for some reason, like there was a big jump. And then 12, and then 13, 15, 16.4, and then back to 1. So 16.67 hit, it ran another update. The update function got run again. So how many is this? 1, 2, 3, 4, 5, 6, 7, 8. We had 8 draws between the function. Now that's this specific case. Each time between the update functions could be different. We could have 1 draw, we could have 0 draws, we could have way more than 8. It really just depends upon the graphics card, the CPU, the, you know, cosmic rays coming down and hitting the computer. What other things are we running? If our, you know, antivirus, you know, if we have Norton, and it comes in and says, like, you know what, we know you're running the game, but have you considered touching all the files at once? What's the refresh rate on your monitor? That's a good question. I think also that, let's see, how will the settings tell me what the monitor itself thinks that it is? Display, no, you're not. Response time is normal, whatever that means. Normal or fast? How about fast? That still won't, like, give me a number. Yeah, I wish this would actually say what it was in the settings, but it doesn't. My guess is that it's ooh, 60 hertz. Okay, there it is. I'm running at 60 hertz. I mean, not terribly, not too terribly surprising. Now, VSync is probably enabled because GGZ enables that by default. If we come over to main, we can actually turn that off. And so, actually, we already have that off. VSync has been set to false. Now, I can turn this on, and we can see what happens to the draws. So take a look at this. We're only getting these like 2.8, 2.6, 2.9. So we can tell that it's resetting. And it's happening once, once per draw loop. Sometimes multiple times. Yeah, I do want it to be deterministic, and having my update be on a very specific step is very deterministic for this. But having our ability to, like, we can't always have vsync false. And we found out on some Linux systems, which is where we're we're aiming to have this run, it didn't actually run the it just ignores the vsync. If I set vsync to true, it won't help. Set your update rate to 200. It should fluctuate again. Okay, so hold on. If I do vsync true, and we set our target FPS to 200, this should be, yeah, so 753 microseconds, that's less than 1 millisecond, then 2.7 milliseconds, 4.3 milliseconds, and then back to microseconds again. However, because I'm aiming to run this on a device that's not necessarily the strongest, I want to keep the target update FPS at a reasonable rate. We might even someday have to drop it down to 50 or potentially even 30, depending upon what we end up having to deal with it. But right now, we're going to stay with 60 because the math is pretty, makes a lot of sense. I'm going to turn vsync to false because we couldn't even turn vsync on. Like, I turned it on, but it got ignored by the Raspberry Pi. So it's just not something we can really deal with. Maybe go with something like 50 or 100. Sure, we can go with 50. And so we'll run this again. We'll take a look at what we got. So let's see, 96 microseconds, 1.6, 2. About 3 almost. So 4.1, 13, 15, 17, 18, and then back to microseconds. If you use 50 or 100, you get more whole numbers. Ooh, that's nice. Okay, so that explains why some people use 50. That is good to know, especially since the Raspberry Pi is running on a 32-bit operating system. So that means I can't really truly use 64-bit numbers. At least I want to stay away from them if I can. So given this is the time since the last update ran. So like, how far are we into the, before the next update is really an alternate way to describe this. So what I want to do is now get to percentage. Like, what percentage am I through that? So if we have this remaining time, we can calculate out. So let the how much time is an update, like, between updates. So time between updates is going to be equal to 1.0 over self dot target update FPS as F32. I do have to convert this into an F32 for ourselves. It means that if you do something like 100 plus 0.1 times 5, ooh, yeah, that is true. Okay, so now that I have the time between updates, that our algorithm is ready. We can now take our remaining time and divide by this. So our percentage, like, between, or maybe fraction would be a better word. So fraction of update. And in the book that I read, this actually could be described as lag. Makes it a bit nicer to debug, that's all. Yeah, like, we can set it to be whatever. The computer doesn't really care, obviously. It's mostly for us, so that's very true. So let's say, like, we have this lag time, and that's going to be our remaining time divided by the time between updates. Now, there's a problem here. This is a duration, and we have an F32, so we actually can't divide by this. let lag equals remaining time. Wait, why are you yelling about this? Oh, because I hadn't saved. That's why it was yelling at me about the previous problem. Okay, so I can only divide between U32s. Well, here's the problem is if I divide by U32, I'm gonna lose all of this sort of like the details of the number. And I need to have everything to the right of the decimal point, otherwise it doesn't really matter. So even though this duration gives me like looks really nice in this debug out, as we can see here, it looks like it's milliseconds. But we also see it has microseconds. So we're gonna have to convert this. So as secs F32, and so that gives us in seconds. Now, if we want to convert this to milliseconds, then we also need to multiply this by 1,000. And that should give us, we should still have the right milliseconds here. Let's run this again and double check. That looks like about the same numbers. We still have milliseconds. So if we take these milliseconds and then we divide by the lag. Now let's take a look at what we have for lag. Well, that doesn't look right. Like that's not a percentage. A percentage starts with something like 0 dot, and goes between 1 and 0 for what we're going for. So clearly our math is really wrong. What we haven't taken a look at is this time between updates. Like what does that really give us? So if we look at that time between updates, we're going to see that this number is not actually what we think it is. 0.02. Okay. So if we're multiplying this by 1,000, we would need to multiply this by 1,000 too. Times 1,000, and I think that's all of you together like that. Not 0. Probably do the parentheses in the area that makes the most sense. So now if we take a look at this, that looks a little bit more correct. That's 20 milliseconds. So now if I take a look at this lag, I know Tigger Gaulis. I'm getting there. Now if we take a look at this, this looks a lot more correct. This is 92.90%, 97%, and then down to 0.1. But if we take a look at this, the way that math works is whatever's on each side, if it's the same, they cancel each other out. Because if we come back to here, and this is like, I know we say that there's not too much math in programming, at least not compared to like, what you might normally expect that you need to have is some kind of like super advanced math degree, but basic algebra is what we're going for here. So if I'm taking this algorithm here, we have the time since last update and update frequency, but if there's something equal like times, if I just choose some arbitrary thing like 10 and I also times 10 here, we get the exact same number. It doesn't matter as long as we're multiplying by the same thing. But if we're doing that, then we could just leave this off and it doesn't change this end number. It's going to be exactly the same. So even though in my brain I'm saying, I'm working with milliseconds, it doesn't really matter. The computer doesn't care because it's the same ratio of unit. And so therefore, if I'm doing the same thing to both sides of the division line, I can just remove them completely. And then we're fine because they cancel each other out. And so if I do that, and we run this again, we have the exact same fractional time here. Okay, so that's good. Now we could probably clean this up just a little bit, or maybe make it like a little bit less, hard for us to calculate. Okay, so maybe we can just do this all in one go. So we can say let lag is equal to, we need to get the left-hand side is going to be the remaining time. And then we want to divide that by this entire thing. And that should be correct. Now we're going to have lag. And if we run this again, we're good to go. Now, if we notice that our percentages, it's not like super smooth all the way through. There are some jumps that happen. So even if our computer is, we can simulate a really slow computer here. If we like drop down to 10 frames per second, we're still gonna get some problems because like it's not gonna be super smooth all the way throughout, and that's just simply because our draws aren't happening evenly. But it's gonna be a lot more smooth than if we didn't do this. You can use more algebra. A divided by 1 over B. Yeah, is A times B. Yes. And so algebra is my weak point. I mentioned this before. I am dyslexic. I have that like sort of weird like flippy thing that happens when I try to do math. And it means that like when I constantly mistake multiply and divide, and so when I try to get into like longer, and by longer I mean like anything longer than this, I start running into sort of like, oh, what's going on? I can't see it, I can't visualize it, I'm having trouble. Oh, and then I just like get really confused. My wife, however, is really good at that, so that's why I utilize her. She helps me out a lot with these type of things. So shout out to my wife for helping out. She doesn't want to be on stream, so she wasn't willing to come and explain it to us, which would have been fun too. Anyways, regardless of this, we now have our lag time. This is the time between frames that we are. What we can do is we can hand this into the draw. So let's start backwards and just imagine that we have this, and then we'll know exactly what we need to pass in order for this to make sense. So we're going to go all the way to the player draw system. Is that dyscalculia? I don't know what dyscalculia is specifically. My dyslexia is more than just math. I get directions wrong too, so like left and right. I will like take left turns when I meant to take right turns when I'm driving, things like that. So it's not purely just numbers, but I don't really know what dyscalculia is off the top of my head. All right, so in our draw system, what we want to do is we want to update this location and have it this actually be based upon, where it's going to be. So what does that mean to us? We need to know what the player's velocity is, like the last known velocity. Well, if that's the case, then we need to have that lag number. So that's going to be an F32. But we also need to know we could just take a look at the velocity itself. However, that's still like an option and draw structs. What if we instead just take in the a reference to the physics engine? So we have the physics system, which is going to be a reference to an option that has a box, that has a dyn, physics system in it. So if we do that, anyway, the reason you mention it is because you can make it lag equals remaining update time times. Ooh, let's try that. Lag equals remaining update time. So there's that. Convert into seconds. Times target update FPS. Wait, really? Hold on, let's try that. Oh, wait, it's not gonna work because I ruined this. Take you and comment you out, and you'll be happy again. Okay, so we're gonna have lag is this remaining update time. And I want to multiply by the target FPS. So that's gonna be just self dot target FPS. And it's gonna have to be as at 32. So if we do that as a debug, and then we also want to like maybe show that it's working correctly. So here's lag. So we'll have both of these displaying out. Let's do a cargo run here. And we see that the numbers are indeed exactly the same. So, perfect. Interesting that with some of these, we're getting a slightly higher resolution on some of the numbers for lag, and then some of them for the other one. That's kind of interesting and fascinating how that works out. But yeah, that works out very well. So we can just do multiplied by this here. Which makes it a lot simpler. So thank you, Tigger Gallus. And we let's see. So, anyways, let's come back to here. We'll re-enable you. So if we have a physics system, we have this lag here. What we need to do is figure out what our like what the our current velocity is. There's less error this way. Oh, nice. Because you're doing one less operation on the floating point number, which is true. And especially since I'm using 32-bit numbers, I can't get like super high resolution as like an F, 64 or an F128. Okay, so we need to get into the velocity of the physics system. So right now that's in an option. So if let some physics system equals physics system. Okay, so that gives us our box here. We need to get the velocity out of it. Well, here's a problem. If I go into physics system, these are the only few things that I'm allowed to call off of a physics system because all it knows about is the trait. It doesn't know about anything like the object that the traits are applied to. So that means we need to do a function get velocity. So self, and we're going to return a, let's do a exactly this thing. Now we could return a reference to it. It's not a terrible idea. It doesn't matter too much. These are like not too much small numbers, and they implement copies. They're gonna copy. There's some things where copy actually ends up being faster than passing by reference. It's kind of interesting that way. So if we add get velocity in here, well, we can now get our velocity out. So we can say let, now velocities, specifically in algebra velocities, allow us to do some, I call it like matrix math on them. Basically, if we take a scalar, which is a single number like lag, can I move? Oh, I can't like move out here. Can I create a new one? I don't need to save this. I think we're fine with this one. Don't save. And we'll do you again. We'll start here again. Okay, so here's how this type of math works. Let's say we have an x and a y coordinates. So x is like, I don't know, 15 and y is 5. And we have this in an object. And if I want to multiply this by just a single number, so times, let's say we multiply this by 10 to keep the math really, really easy. The way this works is we're going to say that this single number, which when you have just a single number like this is called a scalar. And this, which is two numbers, this is a vector 2. Not too surprising since, the N algebra library we're using calls this a vector 2 because there's two of them. A vector 3 would have 3, so we'd have like a z here. We can have a vector 4, we can have a vector 5, we can have as many as like you really want to hold. But it can also be a matrix. Is that correct? A matrix is a vector of vectors. So it's not a matrix. It's I forgot the exact term for it. Anyways, the math for this is if I want to multiply a scalar by a vector, we're going to take this 10 and multiply it by this 15 and this 10 and multiply it by the y. So we multiply the scalar by every single one of these numbers, and that's our end result. So this ends up with x being 150 and y being 50. It's not too like this isn't too terribly hard. And we can get some really cool results in I guess like computer science or like just doing, there's some really cool things that can happen through all this type of math. And when you have like vectors of vectors, and you start doing like these scalar math with it, you can actually get some really interesting results. Now, I don't have to do that math manually myself because Vector 2 has this math built in for me. So what I can say is let our, what do we want to call this? This is going to be our predictive, like where they're going to be, like where we're predicting the location. Well, actually, we're predicting like how much of the velocity we're caring about here. So this is a fraction of the velocity. So I don't know, like the fraction velocity, the part velocity, equal to our physics system dot get velocity. So get that, and then multiply this by our lag. And that gives us, well, you say that it gives us an F32, but I think that this is lying to us. It should give us back a velocity, a vector 2, just like this one. So let's debug U. We'll do our up velocity, and so let's actually rename this to like part velocity. Now I'm going to write the rest of it here, but our debug will help us like know if it's close to what we want it to be. I am Hardliner. Hello. Okay, so given this, if we now have this velocity, I need to update our location by that amount, but I don't want to mutate our location. Now we don't have a mutable reference to the location, so we couldn't do that if we wanted to. But I also can't just update this either. So let's extract out. Also, what if we don't have a physics system? What if this is just some static object that just sits there and doesn't move? It does, like the lag will always be 0. Well, the lag won't even matter. Like it won't even matter what the lag is. So we're gonna do let x equals 0.0. Let x equals location.x, y equals location.y. So we're going to extract out the locations. We're going to make these mutable. And then once we have this velocity, we're going to reference that so I don't lose it. Okay, so we're going to say x is going to be plus equals to the part velocity dot x. Y is plus equals to part velocity dot y. And then when we draw, instead of this location dot x and location dot y, we're simply just going to say x and y. This specific x and y. So we're taking where is the location according to the last known update, using the lag between the frames, but between the ticks, where would it be? And then positioning it there. So a little tiny bit more work for our draw loop to do when it's going through, but it's going to look so much nicer. And the higher frame rate that we get, the nicer it looks. But when we go drop down to lower frame rate, it doesn't look quite as terrible either. So it's a win-win no matter how we go. Now, of course, we drop down too low. It doesn't matter what we do. It's going to look terrible, but it's just not going to look quite as terrible. Let's go ahead and make this pass. So first of all, you're yelling at us because we need this lag added in and this physics system. So we need to go to the trait and add in u here. And you need to know about the physics system. Okay. Then we need to, so what's next? Come over here to the player physics system. We need to implement our missing member, get the velocity, and we're returning a reference to the vector. So that's going to be just a reference to self.velocity. And that's that. Now, no more errors. Now, is that true? Like, that shouldn't work. Because our player draw system, when we draw, these things need to be added in. So an entity, when we draw you need more than this, don't you? We need to add in the lag and the physics system. So now we need a lag and a reference to self.physics system. Well, if we have a lag there, we need the lag here. Okay. And then out of here, jump out. So in the entity, we're at the world. And that means that was our draw, yeah. In the world, in our draw loop, we need the lag here. And then for each of our entity draws, we add in the lag. Then going back even further, go to the library. And for our draws, we have the lag, so we can just pass this in. Now everything should work. So let's go ahead and run this. Now we did put that debug inside of the draw so we can see what we're getting out. And we can see that indeed it is a vector that we're having. So for some reason, Rust Analyzer is just yelling at us for no reason. It's saying, hey, this is an F32. No, it's not. It's a vector too. It's just lying to us. Thank you, Rust Analyzer. I love you 99% of the time. Okay, so let's show what this looks like at various different target FPSs here. So we see what it looks like at 50. I'll run this again. Nice and smooth. Now, if I run this at 100, This computer can handle that, so that's not going to be a problem. Now, by 100, our gravity force gets screwed up, so we have to compensate for that in order to actually be able to watch this. So nice and smooth movement. And then let's say we drop this down. Let's say things are working really poorly. Like we're getting 30 frames per second. And so we might move to like 1.0 for our gravity force. Okay. Not too terribly bad. Let's do like 0.7. That will be a little bit easier to see. Okay. Sort of decently smooth. There's a little bit of a jump at the first beginning when it loads up. That might be something we can do where we don't actually start the game off right away. It's showing some kind of like starting soon screen. And so for all the sort of like everything loading in and starting to update before the draws happen, that won't really be a problem when we just have like a starting soon screen showing. But let's say we drop down to really terrible. We go down to like 10. And let's say we have like a 5.0. So this means 10, so 1 over 10, 0.1. What is that? It's every 100 milliseconds, I think. It runs the update loop. But it's still decently smooth looking. It's not until we drop down to like 5 or even 2 that things just get really terrible. And we can still see it's like, it's smooth. It's not nice, but we're not fully punishing you for having a potato as a computer. However, at 2 frames per second, like there's not anything you can do if your computer is running at 2 frames per second. That being said, if your updates are taking for some reason a long time, but you're able to get several draws out, at least it looks decently good. What's important here, though, is we move this back to 50, and we have our 0.1. We can now implement some features that are interesting. So I was at I'm Hardliner's stream yesterday, and he was playing Celeste. And one of the features they have is the assist mode, which allows you to set the game speed. We can now just cheaply do that by updating our target update FPS, but all the other math is going to remain the same. I don't have to like do anything else crazy. I can now just say, you know what, you're 30. Like maybe we have like bullet time or something, and if you press spacebar, time slows down. All that really does is change our update frequency. So anyways, there's a lot of really cool things we can do about this, and it makes our game look more appropriate. Especially since we're so used to games that are running at really high refresh rates. The bullet, we want to track the bullet all the way across the screen, like things like that. And that's what we got. So that was our interpolation for in between frames. So I'm going to go ahead, before I forget, and send all of this code up to GitHub. So it's this. We are drawing the entities at the appropriate locations between update ticks. Tigger Gaulis, wait. So maybe I should have waited until you had the next thing you're no doubt typing. Where do you do the interpolation between the previous and the current position? it's not the previous and the current position. It's the current position and the next position that I'm doing. And I'm doing that in the player draw system right here. So I'm taking the known velocity that we have, and I'm saying, given our known velocity, let's go ahead and move us over, sort of like predicting where you're going to be. And I definitely don't need that debug anymore. Now, where I got this from, because I didn't invent this myself. Like I didn't even figure that out. It's not interpolation. It's dead reckoning extrapolation. Oh, thank you, Utsby. You're right. Dead reckoning extrapolation. Okay. Thank you for correcting me on that. I get this from this game loop chapter of the Game Programming Patterns book. If we go down, it like talks about the different types of game programming patterns. And we're doing the most complicated version of it, which is this one right here. And this is sort of like the benefits and potentially negatives of it. Doesn't mean we're showing a position one frame ahead. We're not showing a position one frame ahead. We're showing the positions between the frames. So I'm never actually going to show the position for the full velocity ahead, only if it's like 1.0. But then if it's 1.0, it is the next frame, and that number is never going to be there. Chantilly, hello. Where is the code example for this, where they describe it? Right, okay, so now we have this residual lag. We update the game at a fixed time step, so that's that 50 frames per second. But we render at arbitrary points of time, which is just allowing, the computer just renders whenever it can. And this means that we have our renders are happening in between the updates. And so we have something like this. This is very similar to that timeline that I drew out. So they say, imagine a bullet is flying across the screen. On the first update, it's on the left-hand side. The second update, it moves to the right-hand side. The game is rendered at a point in between those two updates. The user expects the bullet is in the center of the screen. With our current implementation, it'll still be on the left-hand side. So this is making it so that the bullet is rendered exactly where it is, which is a prediction of where it would be the next time that the update happens. And that's what we're doing here. We're able to get the frame thing working. Yes, I am. Peyton Rules, rating with a party of 4. Welcome. Hello, Peyton Rules. How's your stream? Also, hello, all raiders. Why the heck are you still not following me? I don't know. But welcome. Thank you for the follow. Peyton, how was the stream? What are you working on today? While I'm waiting for this, we're gonna play the Get the Streamer game because we got raided. It's going to be a chance for you all to throw things at me, and I'm going to try to avoid them here. You are encapsulating a mutex mode. Oh, that sounds fun. Got some flaky tests, and likely. Oh no, flaky tests suck. They're terrible. All right, so the way this game works is you're all going to use these commands that we see on the right, and I'm going to try to avoid them for as long as this timer exists. So far, I think I've won like one game out of everything, but maybe we have a few enough people here that I can survive this time. No! Oh, I got hit. Oh, you all won with Chantilly. No, B Porter beating out with the high score there. Congratulations. You are catching up, yes. I have it so that if you get the hit, it's 10 points, and it doesn't matter what you hit me with. So you can hit me with a heart, you can hit me with anything, you get the 10 points, but just dropping is 1 point. So I can't remember if I put in. I don't think I actually ever put in the limiter in there. So the mods sometimes take advantage of that and slightly cheat by just having a rain of fire and don't really care about killing me because they can get like 100 points just by dropping 1,000 fires. All right, so what we've been working on is this. I mean, I hesitate to call it a game engine because it's sitting on top of a game engine. So it's really a template that is going to be used to create multiple games. So I'm going to be able to like take the template, then customize it, tweak it a little bit, and then we have a game. Then I can improve the template for the next game and then make another game. And I'm taking my time with this one. The last game I was just trying to like rush a little bit too fast. I'm taking my time with this so we can just do it right, make sure it's working, and everything actually looks good. So what we just implemented was extrapolation of what happens when you have draws that are happening at not the same rate as the updates. And I have to do that because I'm not running VSync mode. In fact, I'm planning on running this on a Raspberry Pi. We tested in GG Easy. Raspberry Pis just they just ignore my VSync command. So therefore, I have to handle that. But what that means is I can say, okay, if we have an update here and a bullet is over here, and the next update, the bullet is over here, then in the middle, it should be over here. So we're going to display the bullet in the correct spot for each of our renders. And that's what we just ended up implementing here. So it's not too terribly complex, but it is. I mean, it's algebra of like having to figure out where you are, where you're going, and then do that. Now, of course, it's true. There is a chance that something happens in between, like at the next update, and therefore it's not actually going to continue going through there. That's going to be a rare event. Also, most people won't notice because our movement is going to be pretty nice. However, the way we can visualize like how this looks is here's our target FPS, where I am, where I'm going. That sounds like philosophy. Game dev is like philosophy, isn't it? Where are we going? And where are we in between every time we think about where we're going? Okay, so let's say our target FPS, our updates are at 50 frame, are 50, and our draws are just whenever the computer feels like it. It's an infinite loop. It draws as fast as it can. If this happens, then dropping a ball at 0.1 gravity force per frame looks like this. Okay, not too bad. If for some reason I decide to slow the game down and go down to 2 FPS. Now, if I have this gravity force be it at this level, it's going to be really terrible. So let's make this a 5.0 gravity force. And I want to take out this system. So we're not doing this. We're just undoing everything we just did. But I can now show this is what it looks like. Just sort of stutter. If I add this back in and I rerun this, even with that 2 milliseconds, 2 frames per second, it's still stuttering, but it's actually kind of smooth stuttering. So it's not quite as bad. I mean, 2 frames per second is, there's nothing we can do. That's going to be pretty terrible no matter what. But what that does mean is that if we have 10 frames per second, let's go down to I don't know, 2 gravity. It's decently smooth. This is going to give us the ability to have a slow mode where I can just update our target FPS to something lower. And so we only update the physics very slowly in bullet time, which will be nice for us. However, we're going to stay with 50 for the most part. And with that, we have to go with 0.1. And we're back to here again. So let's go ahead and update. We have 16 warnings. Let's fix all of those. So we need this color and draw mode. Don't need you. Don't need any of you. Apparently a bunch of unknown words. You're fine. Drop param and mesh. Don't care about you. This mint 0.2, we're not using you. And use the create game state, we're not using you. Bunch of more unknown spellings of words. Okay, more unknowns. Or more unused. You, this 0.2 is not used. You should just be black. This keeps on popping up, and it drives me crazy that Rust Analyzer is screwing up like this, where it's telling me that we have these problems in the macros that's inside of GGEZ. But if I run this, so cargo build, I get no warnings whatsoever. I get no warnings, no errors. That's just Rust Analyzer screwing up, which it really, yeah. And I don't know if it's Rust Analyzer or if it's the VS Code interface to Rust Analyzer. It's just driving me crazy. But what can we do about it besides changing our editor? I mean, I could go back to RLS, but everything else about Rust Analyzer is amazing. So, okay, maybe down to 95% love. All right, let's go ahead and save you all off. So removed warnings and push up all this code. So all of this is available at Bang Repo. If you want to go take a look at everything that we just did in that last branch, we are in the main branch. So it should be pretty easy to find. All right, so given that that's where we are, what's like the next thing that we want to do? I probably want to start implementing. Well, like eventually, I want to get to something where like our entity bounces off other stuff. But if I want to do that, I'm gonna need to like position items and like um, get like add them into the world. Let's go ahead and create a grid so that way we can eventually have like a camera system that follows our player around. And the easiest way to determine if our player, like the camera, is actually working, because if we just have like a static color background and the player's moving and the camera's following it, how can we tell if it's working? So a grid that's based upon the world width and height, and then having that not like be separate from the camera width and height, like what's on screen, is going to be helpful here. So I'm going to start over here. We're going to say that we have pub world width. You're going to be an F32, pub world height. Does GGEasy use generated code? Go.rust has problems with Rust Analyzer because it generates C bindings and Rust Analyzer doesn't see them by default. You know, I don't know. It's a good question. I don't think I've looked into that before. I don't think that it uses too much in the way of generated code, or if it does, it's very simple, basic generated code. But I haven't like delved that deeply into GGEasy to like read through the entire source code to see exactly what they're doing. Everything that I've done is pretty simple so far. All right, so if we have our world width and our world height. Now the other thing is that if I want a grid, what does that look like? A grid, like let's imagine that our world is this. Like this is our world. But our camera is actually going to be, oh, that's interesting. Our camera is, oh, okay, hold on. Come on, let me draw again. Stop moving. Our camera is really just going to be something like this. A visualization of this entire world. Something like this. Like if our world is really gigantic, it might be something like this. Maybe this, and then this gets moved around inside of here. Most likely following the player, but we can get interesting things where if the player starts down here, for example, and the end is up here, then we can load in the player, load in the world, load in all the enemies, and then like show the player, like scroll over to the end to show the player where that is, and then scroll back to here like that, drawing everything along the way so that the player knows exactly where they're going. Okay, so what I want to do is I want to create some of these lines. Let's make them like this. I want to make a grid that's much better than this, obviously. I want them to be straight in real life. So imagine these working like that all the way across. Now, for each of these squares, I want these to be standard world units. And that's going to allow me to, let's see, how can I grab that previous one that I created? I don't know if I can. I have selection, but I don't think that's not exactly what I want. I want to select you again, but I can't. Oh, okay, don't do that. I want to create like basically standard world units here. And then that way I can say like, hey, in this spot, I have like a floor, and you know, it takes up like 100% of the spot. Maybe it has a width, maybe it doesn't. But we're going to be able to use a grid to then determine exactly where things go. So that's going to be the next thing that we're going to work on, which is drawing this grid out to represent like a standard world unit and what that looks like. So we have a pub world width, and then we're going to have a pub like a world unit width F32, pub world unit height, which is an F32. All right, so let's add these in. World width. Let's make this. Okay, right now we are working with. Where's our main? 1280 by 720. So if we want to make this bigger, like a lot bigger, then that's where we're gonna set this to be. Width, it's gonna be 1720. Let's do something like I don't know, 10. Let's see, what did I say this was? 1280, 1280. So if I do something like 5000. And let world height. We can actually make this a square. So 5000.0 for the height, and let world units width is going to be, let's make you, let's see, so 5000. We probably want to do this something nice and small. Something like 10.0. And I kind of like the idea of making these squares for right now. Now these are all in pixels, so I'm going to save them off. So we have world width, world height. So given this, if I want to draw the grid, in our draw here, so this is going to be the world. So we now need to have the world probably track what it is, like its width and height. So let's add these in here. So we're going to have a width, it's an F32, and height is an F32. So we're going to take in a width. And we can actually maybe have like a set size. So our default is going to have width equal to, we can do something just silly, like, well, we can just do 5000. We can just set this to 5000.0. Height equals 1000.0. It just needs to be some kind of number that we can deal with here. And then we add in u with height. And then we're going to have a test in here to set our width and height. So CI test set world size. Let's let mute world, which is a type world default. Let's also set, like, we're going to have this assert equal. That the world dot width is going to be, we know that you should be 5,000 to begin with. So 5,000.0. And then if I set this, so we want world dot set size, and if I want to set something like 10,000. Now, once I get to like certain numbers like this, you can actually use an underscore between numbers to help sort of see them instead of commas, which actually helps out a lot. So if I do 10,000 by, let's say, 7,000. Then I would assert equal that the world.width should now be 10,000. Assert equal world.height should be 7,000. Okay, so that's what we expect to have happen. So you're yelling at me that we don't have a set size. Let's implement that. And this is going to be a new size. That's going to be a width. We're actually just passing them two in there. So instead of this tuple, it's actually just the width, which is an F32, and a height. The moment you misread mute as newt self. Yeah, I know it happens. And we're gonna return self. Now the reason why I'm doing this is sort of like the builder pattern here is that way when we're creating the world, we can basically just do it all in one go. However, later on we may decide that we want to like change the world size for some reason, and if that happens, then we can sort of like either add a new function that does it differently, or I don't know. We'll have to play around with it. But okay, so given this, we're going to do self.width, self.height equals height, and return self. And then you're going to be yelling at me because world, we need to do world equals world at set size. Then you're yelling at me because we're doing the wrong kind of compare. So this is going to be allow flippy float compare. You're all happy if I run this test. We're all good there. So then what's the next thing? If I now have the size, we do want the like we can now actually set this. So in our main library, when we're creating the world, so we can say like this world set gravity, and then dot set size, and then the width is going to be the config dot world width world dot config dot world config dot world height. All right, so that's how we're sort of dealing with this, and that's where we're using the builder pattern to make this look really nice. Durelectric, I don't think I pronounced that correctly, but you want us to change the music station. I might have to refund that because we're reaching the end of my time anyways. So I might just want to turn it off right now. Basically, we're going to continue on next time with this and drawing the grid for the world out, which will then allow us to start moving around and having the camera follow the ball down as it falls down the world. But that's gonna be a fun sort of grid system that we have to set up, which it'll be interesting. So I'm gonna go ahead and close all of these down. Let me go ahead and refund those points back to you. Sorry about that. Then I'm gonna change these up. So this is gonna be work in progress. Draw the grid to the screen. And that'll help me remember exactly what we're doing. All right, so that's pushed. Once again, all of that code you can find at Bang Repo online, and you'll be able to follow along and sort of like see what we're doing with this. So since we have 11 of you, I'm going to switch over to the ending screen, so everybody knows that I'm ending. Let's go find somebody to raid. Who's online? Is there somebody? We've raided Begin Bot a lot, so I want to avoid. I don't think we can raid somebody else. Does anybody have a suggestion for who to raid? Oh, come on, browser. You can load for me. My browser isn't loading Twitch up for some reason. It's completely frozen. So that's not good. Well, since I can't actually see Twitch to see who to potentially raid, I'm just going to end it right here. Thank you so much for stopping by. I'll be back tomorrow morning at 7 a.m. Mountain Time to Windy Beard Games. Let's see if I can actually load that up and see what they're doing. Windy Beard Games. With the advertisement that plays. But yes, I'll be back tomorrow morning at 7 a.m. Mountain Time to work on displaying the grid out, and it'll be fun. All right, I'm gonna set up this raid. I will see you all next time. Just hang out for a few minutes if you want to head on over with that. Anyways, have a great rest of your day, and I'll see you all next time.